researchers have discovered evidence that two kinds of black hole-powered galaxies observed by NASA's Fermi Gamma-Ray Space Telescope are distinct sides of the same cosmic coin. By figuring out how these objects, known as blazars, are dispersed throughout the cosmos, the researchers propose that the seemingly unique characteristics that characterize each class more likely represent a shift in how the galaxies draw energy from their central black holes. According to lead researcher Marco Agello, an astrophysicist at Clemson University in South Carolina, we can think of one blazar class as a gas-guzzling car and the other as an energy-efficient electric vehicle. Our findings imply that we are actually witnessing hybrids, which use their black hole's energy in various ways as they mature. Active galaxies feature exceptionally bright cores that are fueled by black holes with masses ranging from millions to billions of times that of the Sun. As gas approaches these supermassive black holes, it forms an accretion disk and undergoes heating. Close to the edge of the black hole, through mechanisms that remain poorly understood, some of the gas is expelled from the disk in jets that travel in opposite directions at speeds approaching that of light. Blazars represent the most energetic category of active galaxies, emitting radiation across the entire spectrum, from radio waves to gamma rays. They constitute over half of the discrete gamma-ray sources identified by Fermi's Large Area Telescope, which has recorded more than 1,000 such sources to date. Astronomers believe that blazars appear particularly bright because they are oriented in such a way that one of their jets is nearly aligned with our line of sight. Observing almost directly along the path of a particle jet moving at relativistic speeds, the emissions from the jet and the surrounding region become the most prominent features in our observations. In order to qualify as a blazar, an active galaxy must exhibit either rapid fluctuations in visible light over timescales as brief as a few days, significant optical polarization, or emit brightly at radio wavelengths with a flat spectrum, which refers to a spectrum that shows relatively minor variations in brightness across adjacent frequencies. Astronomers have recognized two distinct models within the blazar category. The first, referred to as flat-spectrum radio quasars, FSRQs, display strong emissions from an active accretion disk, possess much higher luminosities, have smaller black hole masses, and demonstrate lower particle acceleration in their jets. The second model, known as BL-LAX, is predominantly characterized by jet emissions, with the particles in the jet achieving significantly higher energy levels, while the emission from the accretion disk is either weak or completely absent. Large galaxies form through the collisions and mergers with numerous smaller galaxies, a process that occurs more frequently as we look further back in time. These collisions supplied abundant gas to the developing galaxy and kept the gas in motion, facilitating its journey to the central black hole, where it accumulated into a vast, hot, and luminous accretion disk similar to those observed in gas-guzzling FSRQs. Some of the gas near the black hole fuels a jet, while the remainder gradually falls in, increasing the spin of the black hole. As the universe expands and the density of galaxies diminishes, galaxy collisions and the influx of gas they provide to the black hole also decrease. Over time, the accretion disk becomes less populated, but what remains orbits a black hole that is spinning faster and is more massive. These characteristics enable BL-LAC objects to sustain a powerful jet, despite the relatively small amounts of material spiraling toward the black hole.